The beginning of artificial intelligence is in the ability of the computer to make decisions based on certain pieces of data, whether it be data that's inputted into the computer, data it already has, whatever. It allows the computer to actually respond to things. So these decisions are made through something called conditional statements. And we're going to go ahead and just start off by showing you one of them. This program takes in a number and then gives you some information about it. And then it asks about taking in some words, and then it'll tell you information about those words. As you'll notice, I gave it the same word twice, once where I typed it in code and once where I wrote it as a user, and it said they were equal. I'm going to try running this program again. I'm going to give it a different number this time, -13. Tells me some information about the number. Tells me what x is equal to, which is just some variable. Asked about what I want to set this variable y equal to. I'm going to set it to a different word this time, hi instead of hello, and it will tell me that x and y are not equal, but that they do have the same first letter, which is pretty cool. I see now that x and y are not equal, but they do have the same first letter. That is true. I'm going to try it one more time. Give it 9. Notice how it gives me information about the number 9, and then I give it a completely different word from hello, and it just simply tells me that x and y are not equal. So this program, of course, has very limited use, but notice how I have these different statements coming out based on what you type in. This is, of course, a very basic part of a program that we take for granted, but it is something we have to learn. I hope you're pumped for this lesson. Let's go ahead and give a brief aside to something called logical operators, like the arithmetic operators, plus, minus, divide, multiply, modulus, and exponents. The logical operators are symbols that are basically necessary for accomplishing some very basic things. These logical operators are equals, or is equal to, is not equal to, greater than, and less than. And that's really it. That's all we're going to really need for this. Just make sure you pay attention to the fact that is equal to has two equal signs, whereas we've been doing, variable assignments, and we've just simply had one equal sign there, and that's been fine. When it comes to comparisons, you do need two equal signs. Then also notice how the not equal to has an exclamation mark. That is necessary for that one. And just make sure you have those down in your notes. And then lastly, I guess, again, part 2. Notice the greater than and less than. Remember, the big side faces to the bigger number, or to the bigger character or word. Alright, let's take a look at an example. So right here, we have the code for the program we just saw running. You might recognize that it starts off asking you to enter a number, and then it's going to go enter and make sure that is a floating point number, and then does something that you probably haven't seen before. At least if you're not familiar with programming, you haven't seen it before. One thing I do want to let any experienced programmers know who haven't dealt with Python before, you notice how I don't have parentheses around any of these ifs and else if statements. You don't need them. You do need a colon, and you do need to tab forward, but otherwise you don't need anything else really special there. The other thing is to notice that else if is just L if instead. Alright, now back to learning for all of the newcomers. This right here is called an if structure, or conditional statement, or any real combination of those words. You see, what it does is it just looks at it and says, okay, well, if this condition is true, then do everything that's underneath it that's tabbed forward until the next non-tabbed thing. So let's say, for instance, I was checking to see if x is equal to 13, because for whatever reason I wanted to see that if they typed in the number, and I'd say, hey, that's a lucky number, you know? And I could just keep adding in things, and it would keep doing them as long as I kept putting them in and kept putting this tab right here. And then the first time where I didn't have it tabbed, that would be the end of that if statement. Now it's important to understand where the if statement ends. I'm going to remove this, because it's basically a hypothesis statement. A hypothesis statement from your science classes. Remember, in science, if blank is true, then blank. And that's kind of what we see here. If this condition is true, then print out that the number is positive. Which, if the number is greater than 0, that is the definition of a positive number. Versus, if it is less than 0, then that's the definition of a negative number. And if neither of those things are true, then it's just 0. And we represent that through the if statement, which checks to see if x is greater than 0. The el if statement, which does check this as long as this one was false. So if, for instance, I have been checking if x is greater than 0, if x is equal to 13, in both of those cases, in this case, this elif would not actually occur because this was true, so this one is ignored. That's kind of what the magic of these else parts, whether it be the else, if, or the else, is that they do not run if any of the statements before them run. In a very similar way, this else statement down here will not run if either the if or the elif statement run. And that's actually pretty important. One, because it's going to help you for tracing your programs, for understanding how they work, but also because you'll notice something. I want an easy way of categorizing numbers, and these are 3 pretty easy categories to make: positive, negative, and 0. And they have absolutely no overlap. There is no number which could fit for these for more than one of these conditions. And so this is the perfect kind of way to show off an if, else if, and else. Similar to that is I have this if and else. I do not need to have any particular number of conditions. I can have just one. I could have just the if on its own. But oftentimes we do have an else with it. So this one, for instance, if x modulus 2 is equal to 0, well, in that case, remember, modulus gets the remainder, and this is actually the definition of an even number. Basically, can 2 go evenly into this number? If it can, it's even. If it can't, it's odd. And that's it. This right here, I think, is a pretty good introduction to if statements, to these conditional statements or if statements that are kind of the beginnings of really having effective coding. What I would say then also is that coding statements really make a branching path for your program. This is called a control structure. It creates a more custom experience for your user because the input really does make a difference in how the program runs. You saw that earlier when it did change what it said about it. Notice how these two are supposed to kind of piggyback with each other. If you have a positive even number, then it will print out this number is positive. It will not make a new line, and then it will print out the second part of the statement, and it is even, as if they were all, as if it was just one print statement. This is why we need that end equals from before, and this is what we can do adding in this if statement, is we can produce this sort of output. Output that looks like it was all part of one thought, even though it is 2 completely different if structures. Moving on, we can also do this with strings. Notice this is the part where I go ahead and just hard code one variable, and then say to the user, hey, that variable equals this. What do you want to set y equal to? and then we'll take that number, that word, and it won't convert it to float, and it will just store it in y. Then it will tell us what we just typed, as well as what x is, and it will tell us some data about it. Again, I'm using that end equals thing to take care of it. We'll jump into what's happening down here in just a moment. But notice I then check to see if x and y are equal. It works the same way that numbers do. Again, two equal signs, and just simply checking to see if the words are the same. If they're both hello, then there you go. If they're not, then it will go down here and say they are not equal. Now then I added in a little bit more stuff. I said x and y are not equal, and I just said, okay, but don't make a new line just yet. Then I did what's called a nested if statement. And I'm going to write that right here, nested if statement. Now notice, remember when I said earlier that whenever you have an if statement or an else, everything below it that's tabbed forward is a part of it? Well, that's still the case here. This nested if statement is an if statement that's inside of an if statement. And yes, I know it's else, but bear with me. I guess I could perhaps then change that to be a bit more conditional statement. So it's a conditional statement inside of another conditional statement. That basically, these things only happen if this one does. So if this one happens, we ignore all of this. But if this one does happen, and this happens to be true, then we'll go ahead and print out that. Otherwise, we won't do anything, because we don't want to. Because all I'm checking here is to see if they have the same first letter. We'll do a bit more of that in the next exercise, but as you can see right here, I'm just trying to add on a little bit more. I'm trying to say first they're not equal, but then if I figure out, oh, but they do have the same first character, then I can go and print out again and say, oh, comma, but they do have the same first letter. And that just adds a little bit more intelligence onto the program. Like when we went in here and said hi, and it says, hey, they are not equal. Oh, but they do have the same first letter. It adds a little bit of flexibility onto it. It can now do some stuff that it couldn't do before. I'll give it the word kazoo, and it's going to say, yeah, they're just not equal. It doesn't have any answer for you when you say kazoo, because they're just entirely different. But that's okay. It has some flexibility, it has some depth, it can do other things. And this is just kind of an intelligent way of using these conditional statements, which again are the beginnings of artificial intelligence. Let's move into a slightly more complicated exercise.